Now let's think about what the power of an FM or PM modulated wave is going to be. Remember, one of the things that we want to do is we want to be able to use less power when we're sending a message, because that will save money. So recall that the power of the signal is given by this definition. Now let's find the power of some general sinusoid signal, A cosine omega t. So starting from the definition, we'll substitute our signal in. When we substitute our signal in, we can then take the integral. If you want to find the integral, you could look this up in a table or using something like Wolfram Alpha. Then we'll evaluate the integral. We'll use some things we know, some trig identities, to simplify it. Then we'll change it a little bit, distributing the minus signs through. Then we'll simplify. We'll distribute 1 over t through. Then we'll simplify a little bit more until we arrive here. Now, if we look at that second term, we can see that looks like a sinc function. And if we remember, as for a sinc function, if we took omega t to infinity, that function is going to approach 0. So that means that if we take that limit of the power, we'll see that the power of some general sinusoid wave is equal to the amplitude squared divided by 2. So what if that frequency of our original wave was going to change? So what if we wanted to find the power of some sinusoid wave, A cosine 2 omega t, instead of A cosine omega t? Stop the video and think about what the power will be if we double the frequency. As you hopefully realized, even if we double the frequency, that second term, as we approach infinity, is always going to reach 0. That means that regardless of the angle, even if we double that frequency, we're still going to have the same power, which is the amplitude squared divided by 2.